Enterprise Java Beans Architecture. Here you can see Enterprise Java Beans Architecture diagram with Oracle 8i. Jakarta Enterprise Beans EJB, formerly Enterprise Java Beans, is one of several Java APIs for modular construction of enterprise software. EJB is a server-side software component that encapsulates business logic of an application. An EJB web container provides a runtime environment for web-related software components, including computer security, Java Servlet Lifecycle Management, transaction processing, and other web services. The EJB specification is a subset of the Java EE specification. The basic ways in which EJBs can be assembled, or the basic EJB architectures, can be described in terms of which kinds of beans or J2EE components are used, how client applications access them, and how the underlying domain objects are represented. The EJB architectures can be fundamentally divided into three categories: an entity bean architecture, a session bean architecture, and a session and entity tiered approach. Each basic architecture also has variations and refinement that can be decorated with a variety of J2EE components. The EJB specification does not dictate how enterprise entities are used, but it is clear from the evolution of the specification that certain architectures are assumed to be dominant. Some of the recommended architectures are explained in the J2EE blueprints. This document should be reviewed for more information about J2EE and EJB architectures. Here you can see a remote entities architecture. This illustration shows information flow through remote entities architecture. Information flows from the FAT client through the remote interfaces of the entities that reside on the server. The entities rely on the database for their values and attributes. If entities alone are used, then they must have remote interfaces that exposes all of the client servicing methods. In the absence of session beans, the client may only access the entity state through its remote interface and may not traverse relationships except as encapsulated by remote method calls. Only remote references and data may be returned by these calls. Finders may only return remote references as well. Client gain from this approach in that the distribution of the entities is transparent. Clients reference the entities as if they were local and do not need to worry about location. Entities can exist at different locations without client even being aware of it. The converse transparent distribution is that if clients are not aware of the distributed nature of the entities, then they may not be aware of the cost of invoking them. If the entities are fine-grained objects, that each fine-grained method invocation on them will end up being a remote call. The accumulation of this remote method invocation could sum up to a potential serious network communication latency cost. If container transactions are used for each entity operation, a separate transaction will end up being initiated for each method invocation. This could introduce excessive and unnecessary transaction management overhead if client demarcated user transactions are not used. Since entity beans are intended to be components, there are more restrictions. There are more restrictions placed on them than on regular Java objects. For example, thread spawning is disallowed. This may impose limits on how they can be used to model certain domain concepts. The limitations should be well understood and compared against the model to ensure that they are not discovered too late in the design phase. In general, however, this architecture is less desirable than other architecture types. The relationships limitations imposed by EJB specification are often an impediment to using this approach. Advantages: increase distribution, potential for greater location transparency. Disadvantages: not suitable for fine-grained entities, communication overhead for each method call, transactional cost of each method call, client accesses many EJB interfaces, not single client interface or point of server entity. Much of the business logic must reside on the client. Here you can see a remote session beans architecture. This illustration shows the remote session beans architecture. The client application accesses the session remotely, and the session interacts with the Java objects on behalf of the client application. It is a common practice to apply a session bean layer in front of lightweight objects. This may take the form of the session facade pattern with lightweight entities or other types of persistent objects being managed. Since session beans do not themselves represent durable objects, often a session facade pattern will be used to converse directly with persistent data objects without the use of entities. Persistent data can be modeled using a regular top-link enabled persistent Java objects that are managed by the session beans and mapped using top-links tools. Since a few domain model objects actually live in the client, client's application rarely need to access the domain objects directly. But if regular objects are used, then they may be sent to the client if necessary, since no such restriction exists for them. Session beans are used to carry out most of the application logic. Stateful beans are used for those operations for which client identity is important. while stateless sessions beans can be used for single shot operations. All the EJB benefits of security, transaction, and distribution are available through the session beans. The exclusive use of session beans does not allow for overlay complex client behavior. All client behaviors is limited to services provided by the session beans. Simple client behavior is a general characteristic of all thin client architecture. Simplicity and fast thin client access are clear benefit of this approach. In addition, there is a great flexibility in how domain objects are designed and how these objects are mapped to the underlying relational database tables. Advantages: location transparency on session interface, fine-grained persistent object operations can be batched to combine into a single session bean call to communication to reduce communication overhead. High performance storage retrieval of persistent objects. EJB features available through single point of session bean entry to reduce container overhead. Can relate persistent objects, can pass persistent objects to the client side if necessary. Disadvantages: fine-grained client calls may require explosion of session interface calls. Persistent Java objects not included in EJB specification. Here you can see client. Client is connected to session. You can see session and Java objects are inside the server, and session is connected to Java objects. Java objects are connected to database. Here you can see session facade architecture. This illustration shows the remote session beans architecture. Client application accesses the session remotely, and the session interacts with the Java objects on behalf of the client application. The majority of systems have relationships between application entities. This being the expected scenario, it is well observed and explained by J2E designers. More common, however, is to incorporate the domain logic into the session bean itself. This migrates the business logic from the client to the server, which provides a number of well-known benefits, including ease of maintenance, convenient upgradability, and increased access to server features. Regardless of whether the session bean simply forwards the operations entities or actually includes the application logic as a facade that funds the local entities in its modular approach to remotely accessing server-side objects, it is also likely to be easier to maintain as J2EE specification moves forward. Since session beans tend to experience change to a lesser degree than other components such as entities, the decision to use stateful and or stateless session bean will likely depend on the amount of business logic incorporated into the session bean. Advantages: location transparency on session interface. Fine-grained entity operations can be batched or combined into a single session bean call to reduce communication and transaction overhead. Inter-entity method calls are passed by reference, can maintain entity relationship. All components described by EJB specification. Flexibility to create new local transaction of specific method calls when required. Fine-grained client calls may require explosion of session interface calls. Some container overhead still incurred on each local entity call. Here you can see a client is connected to session. Session and entities are inside the server. Session is connected to entities. Entities interact. Entities are connected to database. Now we are focusing on EJB Client. When one enterprise bean, call it the source enterprise bean, accesses another enterprise bean, call it the target enterprise bean, the source enterprise bean is the client of the target enterprise bean. If you are using EJB 3.0 with annotations and dependency injection, OC4J initializes the instance variable that corresponds to the target reference. If you are using EJB 2.1, you must use JNDI lookup in this scenario. Here you can see the composition of an EJB home proxy in JBoss. Let's begin our tour of the EJB container by looking at the client view of an EJB through the home and remote proxies. It is the responsibility of the container provider to generate the javax.ejb.ejb home and javax.ejb.ejb object for an EJB implementation. A client never references an EJB bean instance directly. Rather, it references EJB home which implements the bean home interface and EJB object. Which implements the bean remote interface. This figure shows the composition of EJB home proxy and its relationship to the EJB deployment. Here you can see the EJB developer, EJB deployer, org.jboss.ejb.ejb deployer is invoked to deploy an EJB jar. An EJB module org.jboss.ejb.ejb module is created to encapsulate the deployment metadata. The create phase of EJB module lifecycle creates an EJB proxy factory org.jboss.ejb.ejb proxy factory that manages the creation of EJB home and remote interface proxies based on the EJB module invoker proxy binding metadata. There can be multiple proxy factories associated with an EJB, and we will look at this more closely shortly. The proxy factory construct the logical proxies and bind the home into JNDI. A logical proxy is composed of a dynamic proxy, java.lang.reflect.proxy, and the home interface of the EJB that proxy exposes, the proxy handler, java.lang.reflect.invocation handler, implementation in the form of client container, org.jboss.proxy.client container, and the client side interceptors. The proxy created by the EJB proxy factory is a standard proxy. It is a serializable object that proxies the EJB home and remote interfaces as defined in the EJB module metadata. The proxy translates the request made through the strongly typed EJB interface into the D-type invocation using client container handler associated with the proxy. The dynamic proxy instance is bound into JNDI as the EJB home interface that clients look up. When a client does the lookup of a EJB home, the home proxy is transported into the client VM along with the client container and its interceptors. Using dynamic proxies, avoid the EJB specific compilation step required by many other EJB containers. The EJB home interface is declared in the EJB-jar.xml descriptor and is available from the EJB module metadata. A key property of dynamic proxies is that they implement the interfaces that expose. This is true in the sense of Java's strong typing system. A proxy can be cast to any of the home interfaces. The reflection on the proxy provides a full details of the interfaces it proxies. A proxy delegate calls made through any of its interfaces to the client container handler. A single method required of the handler is public object invoke, object proxy, method dem, object array args, throws a throwable. The EJB proxy factory create client container and assign this as a proxy handler. The client container state consists of an invocation context org.jboss.invocation context and chain of interceptors org.jboss.proxy.interceptor. The invocation context contains following: the JMX object name of the EJB container being that the proxy is associated with, the JavaX EJB metadata for the EJB, the JNDI name of the EJB home interface, the transport specific invoker org.jboss.invocation.invoker. Interception chain consists of the functional units that make up the EJB home and remote interface behavior. This is a configurable aspect of an EJB. An interceptor and the interceptor makeup is contained in the EJB module metadata. Interceptors org.jboss.proxy.interceptor handle the different EJB types security, transactions, and transport. You can add your own interceptors as well. The transport specific invoker associated with the proxy has an association to the server side detached invoker that handles the transport details of the EJB method invocation. The detached invoker is a JBoss server side component. You configure the client side interceptors by using jboss.xml client interceptors element. When the client container invoke method is called, it creates an untyped invocation org.jboss.invocation to encapsulate request. This is then passed to the interceptor chain. The last interceptor in the chain is the transport handler that knows how to send the request to the server and obtain reply, taking care of the transport specific details. Here you can see a EJB deployer is connected to EJB module, and EJB module is connected to proxy factory. Proxy factory is connected to proxy. Proxy and client containers are inside logical EJB proxy. Proxy interacts with EJB home. Proxy interacts with client container. Client container interacts with JBoss server. Here you can, as an example, you can see a client application. Here invoking EJB method, if you consider that part. Once you have the home interface, for the bean, you can invoke one of the beans create methods to instantiate a bean. Here, for example, then you can invoke EJB's methods in the normal way. Here you can see localhost colon 2481 colon OCRL here. Here, for example, we can employee number is here for example, for Alan, for instance. And here you can see the lookup bean, and here create a bean instance, and create a slot for the incoming data. And get the data and print it here. As an example too, you can see an example of EJB client code. This shows the source code for the sample EJB client application that is part of the VSE connector client. The code is based upon the use of the WebSphere application server as the web application server type. Here define properties specifying IIOP colon // as the provider URL causes the EJB client to search for a name server on the localhost listening on the port number 900, which is the default for the WebSphere application server. In real environment, you would specify the complete URL such as IIOP colon // bank server .mybank.com colon 9019. Here you can see the initial context object is instantiated. Here the home interface of the employer bean is looked up. The string used here to identify the EJB is stored in the EJB's deployment descriptor. You can view the EJB's deployment properties by using WebSphere Administrative Console. Here you can see create a remote interface object to obtain access to the EJB's business logic methods. This call to the remote interface create method invokes the EJB create method of the EJB. Here access the EJB's business logic methods. For example, get some properties of employer 103, employer that has the number 1003. Please be aware, however, that the EJB is always accessed via the remote object. In this example, employer.class in this example, employee number and password are taken from the EJB sample provided with the VSE connector client, which also provide the utilities to fill the sample VSAM cluster with some simple sample data. In this code, you can see an example that configures the EJB client connections, global interceptors, and invocation timeouts using the EJB client element in the wildfly-config .xml file. You can use the EJB client element, which is in the URN colon wildfly client EJB colon 3.0 namespace. To configure EJB client connectors, EJB client connections, global interceptors, and invocation timeouts using the wildfly-config.xml file. Invocation timeout. This optional element specifies the EJB invocation timeout. It has seconds attribute. The timeout in seconds for EJB handshake or the method invocation request response cycle. This attribute is required if the execution of a method takes longer than the timeout period. The invocation throws java.util.concurrent.timeout exception. However, the server side will not be interrupted. Global interceptors. This optional element specifies the global EJB client interceptors. It can contain any number of interceptor elements. Interceptor. This element is used to specify an EJB client interceptor. It has class and module attributes. Class attributes: the name of a class that implements org.jboss.ejb.client.ejb client interceptor interface. This attribute is required. Module attribute: the name of the module that should be used to load the interceptor class. This attribute is optional. Connections. This element is used to specify EJB client connections. It can contain any number of connection elements. Connection. This element is used to specify an EJB client connection. It can optionally contain interceptors element. It has a URI attribute. URI attribute: the destination URI for the connection. This attribute is required. As an exception example, we can consider no class def found exception, no class def found exception, class not found exception. If the client issues either of these, there is probably something missing or corrupt on your client side class path. The exception should give you a good indication of which class is missing, and from this you may be able to work out which jar file to add to the class path. Remember that you need j2ee.jar and the fully deployed jar in the class path. It is unlikely that CICS will issue any useful additional information for these problems. No class found, error : JavaX/EJB/home handle. This indicate that a client application does not have EJB 1.1 level classes available on the class path. Ensure that j2ee.jar is available. These things are under CICS transaction server for Z/OS. And then as an error example, we can consider getting EJB client 000025 error if a EJB is called on a remote JBoss EAP server. Here you can see the error java.lang.illegal state exception, EJB client 000025, no EJB receiver available for handling, app name : remote test remote, module name : EJB, distinct name, and combination for invocation context, etc. Now we are focusing on Oracle 8i. Oracle database, commonly referred to as Oracle DBMS or simply as Oracle, is a multi-model database management system produced and marketed by Oracle Corporation. Here you can see Oracle database architecture on Windows. The Oracle database architecture on Windows, here an Oracle instance is shown as a Windows service, a background process registered with the operating system. The service is started by Windows and requires no user interaction to start. It contains memory structures and threads needed to access the database. The client connects via a shadow thread to the Oracle instance. The shadow thread connects directly with the process monitor. The memory structured inside a shared pool of a library cache and a data dictionary cache. A database buffer cache and a redo log buffer. The threads includes database writer, log writer, process monitor, system monitor, all required while the database is available, checkpoint process, archive process, and distributed recovery process, all optional while the database is available. There is an Oracle database containing data files, control files, and redo log files. Associated with the database is the parameter file, password file, and archived log files. Uh, the internal process architecture of Oracle database is thread based. Threads are objects within a process that run program instructions. Threads allow concurrent operation within a process that a process can run different parts of its program simultaneously on different processes. A thread-based architecture provides following advantages: faster context switching, simpler system global area allocation routine because it does not require use of shared memory, faster spawning of new connections because threads are created more quickly than processes, decreased memory usage because threads share more data structures than processes. Internally, the code to implement the thread model is compact and separate from the main body of the Oracle database code. Exception handlers and routings track and deallocate resources. They add robustness with no downtime because of resource leaks or ill-behaved program. Oracle database is not a typical Windows process. On Windows or an Oracle database instance, threads and memory structures is a Windows service, a background process registered with operating system. The service is started by Windows and requires no user interaction to start. This enables the database to open automatically at startup. When running multiple Oracle database instances on Windows, each instance runs on its own Windows service with multiple component threads. Each thread may be required for the database to be available, or it may be optional and specific to certain platforms. The background processes read and write from various data files depending on your configuration. Oracle database architecture, you can see here. Here you can see required and optional database threads. DBWO is database server, the database writer. It is required. LGWR log writer, it is required. PMON process monitor, it is required. SMON system monitor, it is required. CKPT checkpoint process thread on Windows that runs by default on Windows. This is optional. ARCH and 0 archive process on thread on Windows, optional. This is optional. RECO distributed recovery background process, and this is optional. You can view background. You can view running background processes by issuing this SQL command. Select asterisk from $BG process where PADDR less than greater than comma 00 comma semicolon. Oracle database for Windows is supplied as a set of executable and dynamic link libraries, DLLs, Executable images can be modified using ORA stack to change the size of the stack used by the threads of the Oracle database process. Oracle recommends you use this tool only under guidance of Oracle support services. When we consider file and OS enhancement, Oracle database supports 64-bit I/O to allow use of larger than 4 gigabytes GB. In addition, physical and logical raw files are supported as data, log, and control files to support Oracle real application clusters on Windows and for those use cases where performance need to be maximized. All Oracle database file I/O routine supports 60-bit offsets, meaning there are no 2 GB or 4 GB file size limitations when it comes to data, log, or control files, as there are on some other platforms. In fact, the limitations that are in place are generic Oracle database limitation across all platforms. These limits include 4 million database blocks for each file, 60 KB maximum block size, and 64K files for each database. If these values are multiplied, then maximum file size for database file on Windows is 64 GB. The maximum total database size supported with 16 KB database blocks is 4 petabytes. Raw file support. Windows supports raw files similar to Unix. Using raw files for database or log files can have a slight performance gain. Raw files are unformatted disk partitions that can be used as one large file. Raw files can have benefits of no file system or backing up raw files. As a result, raw files generally used only by high-end installation and by Oracle real application clusters where they are required. To Oracle database, raw files is no different from other Oracle database files. They are treated in the same way by Oracle database as any other file and can be backed up and restored through Recovery Manager or OCOPY. Here you can see a client thread here. Client thread interacts with shadow thread. Shadow thread interacts with process monitor. Shadow thread and memory structures are inside Oracle instance, and system global area is also inside Oracle instance, and system global area consists shared pool, database, buffer cache, redo log buffer, and shares library cache and data dictionary are inside shared pool. Oracle instance interacts with recoverer, system monitor, database writer, and Oracle instance is connected to process monitor, checkpoint, log writer, archiver, and Oracle database data files, control files, and redo log files are inside Oracle database, and Oracle data and there are parameter file, password file, and archive log files also. Here you can see basic EJB component relationships. There are 4 major components that you must create to develop a complete EJB: home interface, remote interface, implementation of a remote interface, the actual bean class, and a deployment descriptor for each EJB. The home interface specify the interface to an object that the container itself implements. The home object, the home interface contains create methods that specify how a bean is created. Home interface with home object serves as a factory object for EJBs. Remote interface specify the method that you implement in the bean. These methods perform the business logic of the bean. The bean must also implement the additional service method that the EJB container calls it various times in the life cycle of a bean. The bean implementation contains the Java code that implements the remote interface and required container methods. Deployment descriptor specified attributes of a bean for deployment and loading into the database. For example, the deployment descriptor declares the transactional properties of the bean. At deployment time, the EJB deployer, together with the application deployer, can decide whether the container should manage transaction support or have the client to do it. Client application itself does not access the bean directly. Rather, the container generates a server-side object known as EJB object that serves as a server-side proxy for the bean. The EJB object received the message from the client thus the container can interpose its own processing before the messages are sent to the bean implementation. Here you can see a client is connected to home interface. Create is passed from client to home interface, and invoke methods are passed from client to remote interface. Server container and Oracle 8i are inside the server. Home interface, remote interface, and bean instance are inside the container. Home interface is connected to bean instance. And remote interface is connected to bean instance, and bean instance is connected to Oracle 8i database. As an example, we can consider deployment steps. The format used in the package EJBs is defined by the EJB specification. This section describes the steps that the EJB developer and the EJB deployer take to compile, package, and deploy an EJB. Oracle 8i supplies a deployment tool, Deploy EJB, that automatically performs most of the steps necessary to deploy an EJB. The Deploy EJB tool deploys only one bean at a time. Step 1. Compile the code for the bean. This includes home interface, remote interface, bean implementation. All Java source files dependent on the bean implementation class. This dependency is normally taken care of by the Java compiler. Use the standard client-side Java compiler to compile the bean source files. The bean typically consists of one or more Java source files and might have associated resources files. Oracle 8i supports the Sun Microsystems Java Developers Kit compiler versions 1.1.6 or 1.2. Alternatively, you might be able to use another JCK tested Java compiler to create EJBs to run in the Oracle 8i server. Step 2. Write the XML deployment descriptor for the EJB. Step 3. Write the Oracle deployment mapping file. Step 4. Create a jar file containing the interface and implementation class files, the home interface, the remote interface, and the bean implementation for the bean. If you have other dependent classes and resource files, it is better to create a separate jar file for these. Deploy EJB tool uses this jar file as an input file. Step 5. Call the deploy EJB tool. See Oracle 8i Java reference tools reference for information on deploy EJB to load and publish the jarred bean. As an error example, we can consider this one: publish error on deploying EJB on Oracle 8i. Publish oracle.aurora.server.tools .scss underscore iiop.tools exception cannot create directory, no access right. This is occurred in Oracle 8i and Windows NT 4.0. Now we are focusing on sessions. A session bean is an EJB 3.0 or EJB 2.5 enterprise bean component created by a client for the duration of a single client-server session. A session bean performs operation for the client. Although a session bean can be transactional, it is not recoverable should a system failure occur. Session bean objects are either stateless or stateful, maintaining conversational state across method calls and transactions. If a session bean maintains state, then OC4J manages this state if the object must be removed from the memory. However, the session bean object itself must manage its own persistent data. Here you can see a sequence of events in a session bean lifecycle. An enterprise Java bean has two client interfaces, a remote interface and a home interface. Remote interface specifies the methods that the object's client can invoke. The home interface defines how clients can create objects, which returns the reference to the objects. The client uses both of these interfaces when invoking a method on a bean. The events that occur when a client invokes a method within a bean are explained in this diagram. The numbers here are correspond to the steps. Step 1, during client 1. Step 1, client 1 lookups home interface for bean X. During JNDI lookup, the database create a session for the server side of the request. Reference to home interface X is returned to the client 1. Client 1, step 3, client 1 invokes create method on home interface X. The bean instance is created within the session that was established on the GNDI lookup. Home interface X instantiate the remote interface X and contain the container instantiate a bean for this client and is destroyed only when a client invokes the remove. The object reference of the remote interface X to invoke methods on bean instance X. The object reference of remote interface X is returned to the client 1. Client 1 uses step 5, client 1 uses remote interface X to invoke methods on bean instance X. Steps 6, remote interface X delegates call to a bean. Step 7, client interface client 1 invokes remove on remote interface. When it's done with the bean instance, this destroys the remote interface and the bean instance. Here you can see a client is connected to remote home interface and remote interface. Create is passed from client to home interface and invoke methods are passed from client to remote interface. Oracle 9 database and container are inside server. container consists of here home interface and remote interface, and bean instance are inside container. Home interface is connected to bean instance. EJB create is passed from home interface to bean instance. Remote interface is connected to bean instance. Bean instance is connected to Oracle 99 database here. Here you can see a stateless session bean lifecycle. This figure shows the stateless session bean lifecycle. There are two states: does not exist and method ready pull. To transition from does not exist to method ready pull, following occurs. New instance method is invoked. Dependency injection takes place, if any. Set session context method is invoked, and the session bean method annotated as post construct or the EJB create method, if defined, is invoked. To transition from the method ready to method ready pull to the does not exist state, following occurs. The session bean method annotated as pre-destroy or the EJB remove method, if defined, is invoked, while the method ready pull state session bean methods can be invoked as the EJB timeout method if the session bean implements the timeout interface. The life cycle for EJB 3.0 and EJB 2.1 stateless session beans are identical. The difference is in how you register lifecycle callback methods. The optional EJB 3.0 stateless session bean lifecycle callbacks method you can define using annotations. For EJB 3.0 stateless session beans, you do not need to implement these methods. Here you can see the lifecycle methods for an EJB 3.0 stateless session bean. Annotation at post construct. This optional method is invoked for a stateless session bean before the first business method invocation on the bean. This is at a point after which any dependency injection has been performed by the container. Annotation at pre-destroy. This optional method is invoked for a stateful session bean when the instance is in the process of being removed by the container. The instance typically releases any resource that has been holding. The EJB 2.1 lifecycle methods, as specified in javax.ejb.sessionbean interface, that is stateful session bean, must implement. For EJB 2.1 stateful session beans, you must at least provide an empty implementation for all callbacks methods. EJB create method. The container invokes this method right before it creates the bean. Use this method to initialize non-client specific information such as retrieving a data source. EJB activate. This method is never called for a stateless bean session bean, providing an empty implementation only. EJB passive. This method is never called for an stateless session bean, provide an empty implementation only. EJB remove. This container invokes this method before it ends the life cycle of a stateless session bean. Use this method to perform any required cleanup, for example, closing an external resources such as data source. Set session context. The container invokes this method after it first instantiates the bean. Use this method to obtain a reference to the context of the bean. Here, a stateless bean is a session with no conversational state. All instances of a particular stateless session bean class are identical. Here you can see does not exist interact with method ready pool, and it interacts with method and EJB timeout. Methods and EJB timeouts are passed here. New instance, then dependency injection, then set session context, then at post construct or EJB create are passed from does not exist to method ready pool. Pre-destroy or EJB remove is passed from method ready pool to does not exist. Here you can see a stateful session bean life cycle. Stateful session bean is a session bean that maintains conversational state. This figure shows the stateful session bean life cycle. There are 4 states. Does not exist, method ready, in transaction, and passive. To transaction from does not exist state to the method ready state, following occurs. The new instance method is invoked, dependency injection occurs if any, and the session bean method is annotated as the pre-construct, or the EJB create method, if defined, is invoked. The transaction from the method ready state to passive state, the container chooses the session bean as eligible for passivation, and the following occurs. Session bean method annotated as pre-passive or EJB passive method if defined in invoked. The transition from passive state back to the method ready state, the following occurs. Session bean method annotated as post activate, or the EJB activate method is, if defined, is invoked. If the session bean remains in the passive state long enough to exceed the passivation method timeout, the session bean moves to the does not exist state. To transition from method ready state to the method ready in transition state, the the following occurs. A transition is started from the method ready state to the method ready transaction state. A transition is started and the session synchronization method after begin is invoked. To transition from method ready in transaction state back to the method ready state, the following occurs for the success case. The transaction commits successfully. Session synchronization method before compilation is invoked. The session synchronization method after compilation is invoked with an argument of true. The following occurs for the failure case. The transaction is rolled back and the session synchronization method after completion is invoked with the argument of false. Annotations such as post construct are applicable to EJB 3.0 stateful session beans only. EJB, the lifecycle for EJB 3.0 and EJB 2.1 stateful sessions beans are identical. The difference is in how you register lifecycle callback methods. The optional EJB 3.0 stateful session bean lifecycle callback methods you can define using annotations. For EJB 3.0 stateful session beans, you do not need to implement these methods. So annotation post construct. This option method is invoked for a stateful session bean before the first business method invocation on the bean. This is at the point after which any dependency injection has been performed by the container. Pre-destroy, annotation pre-destroy. At this point, this optional method is invoked for the stateful session bean while the instance is in the process of being removed by the container. The instance typically releases any resources that it has been holding. Annotation at pre-pursue. The container invokes this method right before it pursuates a stateful session bean. Annotation at post activate. This container invokes this method right after it reactivates formerly pursuated stateful session bean. EJB 2.1 lifecycle methods as specified in the javax.ejb.session bean interface that a stateful session bean must implement. For EJB 2.5 stateful session beans, you must at the least provide an empty implementation for all callbacks methods. EJB create method. The container invokes this method right before it creates the bean. Stateless session beans must do nothing in this method. Stateful session beans can instantiate state in this method. EJB activate method. The container invokes this method right after it reactivates the bean. EJB pursuate method. The container invokes this method right before it pursuates the bean. EJB remove method. A container invokes this method before it ends the life of session bean, life of a session object. This method performs any required cleanup, for example, closing external resources such as file handles. And set session context method. This content invokes this method after it first instantiates the bean. Use this method to obtain reference to the context of the bean. Here you can see does not exist interacts with method ready, new instance, then dependency injection, then post contract annotation or EJB create method are passed from does not exist to method ready, and from method ready to remove or EJB timeout, then at pre-destroy annotation or EJB remove are passed from method ready to does not exist. Method ready interacts with passive. At pre-passive annotation or EJB passivate method are passed from method ready to passive. Post activate annotation or EJB activate method is passed from passive to method ready. Passive is connected to does not exist state. Timeout is passed from passive to does not exist. Non-transaction TX method is connected from method ready to method ready. Method ready interacts with method ready in transaction. Transaction method, then after begin method passed from method ready to method ready in transaction. Commit, then before completion, then after completion true are passed from method ready to TX. Method ready in transaction to method ready. Rollback, then after completion false are passed from method ready in transaction to method ready. As an example, we can consider this code. Here annotation type stateless, component defining annotation for stateless session bean. This is in package javax.ejb. This EJB version is 3.2. As an example 2, we can consider this code. Annotation type stateful, component defining annotation for a stateful session bean. This is in package javax.ejb, EJB version 3.2. Here you can see set session bean access timeout values in as a XML configuration sample. This is under this is in the environment of Red Hat JBoss Enterprise Application Platform 7.4. As an error example, we can consider this one. javax.ejb exception, javax.ejb.create exception could not create stateless EJB. This error occurred under NetBeans 6.9 and Glassfish 3. As an error example 2, we can consider this one, EJB 5128. The Sun Java System Communications Application Server 1.0 error message EJB 5128. A problem occurred while the container was activating a stateful session bean. One possible cause is that the bean code threw a system exception from its EJB activate method. Solution is to check the stack trace to see whether the exception was thrown from the EJB activate method, and if so, double check the application code to determine what caused the exception. Now we are focusing on EJB. Enterprise Java Beans technology is the server-side component architecture for Java Platform, Enterprise Edition Java EE. EJB technology enables rapid and simplified deployment of distributed, transactional, secure, and portable applications based on Java technology. Here you can see a typical EJB architecture. An EJB object consists of a number of different objects. First one, bean itself, which must be written completely by the application programmer. Number two here, home object, which is responsible for creation and removal of a bean. This is automatically generated from an interface specification given by the application programmer. And EJB object, which acts as an RMI remote object visible to the client. It automatically generated from an interface specification given by the application programmer. A client to the EJB, which is written by the application programmer. The bean, home object, and the EJB object will all be embedded in an EJB container, which is run from an EJB server. These are supplied by the EJB vendor and are not the direct concern of the application programmer. Here you can see a client is connected to home and EJB object. A remote call is passed from client to home. Remote call is passed from client to EJB object. Home is connected to bean. Local call is passed from home to bean. EJB object is connected to bean. Local call is passed from EJB to objects to bean. Here you can see a life cycle of EJB 2.1 entity bean with container managed persistence. An entity bean is an EJB 2.1 enterprise bean component that manages persistent data, performs complex business logic, potentially uses several dependent Java objects, and can be uniquely identified by a primary key. This figure shows the EJB 2.1 CMP entity bean life cycle. There are three states: does not exist, pooled, and ready. To transition from does not exist state to the pool state, the following occurs. New instant method is invoked and the set entity context method is invoked with the entity context argument, while the pool state EJB home, EJB find and EJB select methods may be invoked to transition from the pool state to the ready state. Following occurs for a new instance. The EJB create method is invoked and the EJB post create method is invoked, while in the ready state, the following state to the pooled following methods may be invoked: EJB load, business methods, EJB timeout, EJB select, and EJB store. To transition from the ready method to the pooled state, the container select the entity bean as eligible for passivation and then invokes the EJB passivate method. To transition from the pooled state to the ready state, the following occurs for the previously passivated entity bean. The EJB activate method is invoked. The transition from the ready state to the pooled the following occurs for a removed entity bean. The EJB removed method is invoked. To transition from the pooled state to the does not exist state, unset entity context method is invoked. The EJB 2.1 enterprise beans lifecycle methods, as specified in the javax.ejb entity bean interface, that an entity bean with container managed persistent must implement. For EJB 2.1 entity beans with container managed persistence, you must at least provide an empty implementation for all callback methods. EJB create method, you must implement an EJB create method corresponding to each create method declared in the home interface. When the client invokes the create method, the container first invokes the constructor to instantiate the object, then it invokes the corresponding EJB create method. For an entity bean with container managed persistent, use this method to initialize container managed persistent fields. The return type of all EJB create methods is the type of the bean's primary key. Optionally, you can initialize the bean with the unique primary key and return it. If you rely on container to create and initialize the primary key, return null. EJB post create, The container invokes this method after the environment is set. For each EJB create method, the EJB post create method must exist with this argument. For an entity bean with container manage persistent, you can leave this implementation empty or use your implementation to initialize parameters within or from entity context. EJB remove method, the container invokes this method before it ends the life cycle of the entity bean. For an entity bean with container manage persistent, you can leave this implementation empty or use your implementation to perform any required cleanup, for example, closing external resources such as field handles. EJB store method. This container invokes the container invokes this method right before the transaction commits. It saves the persistent data to an outside resource such as database. For an entity bean with container manage persistent, you can leave this implementation empty. EJB load method. This container invokes this method when the data should be reinitialized from the database. This normally occurs after activation of an entity bean. For an entity bean with container manage persistent, you can leave this implementation empty. EJB activate. The container calls this method directly before it activates an object that was previously passivated. Perform any necessary reacquisition of resources in this method. EJB passivate. The container calls this method before it passivates the object. Release any resources that can be easily recreated in EJB activate and save storage space. Typically, you want to release resources that cannot be passivated, such as sockets or database connections. Retrieve these resources in the EJB activate method. Here, does not exist interacts with pooled new instance, then set entity context are passed from does not exist to pool. EJB home is passed from pool to pool, and EJB find then EJB select are passed from pool to pool. Pooled interacts with ready. EJB create, then EJB post create are passed from pool to ready. EJB loads are passed from ready to ready. Business methods are passed from ready to ready. EJB timeout are passed from ready to ready. EJB select is passed from ready to ready. EJB store is passed from ready to ready. EJB activate is passed from pool to ready. EJB passivate is passed from ready to pool. EJB removed is passed from ready to pool. Unset entity context is passed from pool to does not exist. Here you can see a life cycle of a message driven bean. The EJB container usually creates a pool of message driven bean instances. For each instance, EJB container performs these checks. First, if the message driven bean uses dependency injection, the container injects these references before instantiating the instance. 2. The container calls the method annotated at post construct, if any. Like a stateless session bean, a message-driven bean is never passivated, and it has only two states: non non-existent and uh, ready to receive messages. At the end of the life cycle, the container calls the method annotated at pre-destroy, uh, if any. The bean instance is then ready to garbage collection. Here you can see does not exist and ready. Dependency injection if any, then post construct callback if any is passed from does not exist to ready. On message is passed from ready to ready. Pre-destroy callback if any is passed from ready to does not exist. Message driven beans here you can see messaging with MDBs in JMS Java EE programming. Message driven beans is one of family of enterprise Java beans EJB components described in the EJB 2.0 and later specification. Message driven beans provide asynchronous messaging. Other EJB components, session beans and entity beans, can only be called synchronously through a standard EJB interface. However, enterprise applications often need asynchronous messaging to allow server-side components to communicate without tying up server resources. Any application whose server-side component must respond to application events need an EJB component that can receive and consume messages without being tightly coupled to the message producer. In enterprise application, this capability must also scale under increased load. Message-driven beans (MDB) is an EJB component supported by a specialized EJB container. That provide distributed services for component it supports. The MDB implements the JMS message listener interface. The onMessage method written by the MDB developer is invoked when MDB container receives the message. OnMessage method consumes the message just as the onMessage method of the standard message listener object would. You do not remotely invoke methods on MDBs as you do on other EJB components. Therefore, no home or remote interface associated with them. Each MDB can consume messages from only single destination. The message can be produced by standalone JMS applications or JMS components or EJB components. As shown in this figure. Specialized EJB container supports the MDB. This MDB container creates instance of MDB and set them for asynchronous consumption of messages. The container set up a connection with the broker, including authentication, creates a pool of sessions associated with the given destinations, and messages are and manages the distribution of messages among pool sessions. Since the container controls the lifecycle of MDB instances, it manages the pool of MDB instances to accommodate incoming message loads. Associated with each MDB is a deployment descriptor that specified the connection factory attributes and destination properties that the container uses in setting up message consumption. The deployment descriptor can also include other information needed by deployment tools to configure the container. Each such container supports all instances of a single MDB. Here you can see a JMS message produces a JMS component or application, and this is connected to destination. EJB container is connected to destination. EJB instance is in EJB container. Here you can see JMS message service. Broker and destinations are inside JMS message service. Destinations are connected to MDB container. JMS message consumers. MDB instance is inside MDB container. It has MDB instance has on message method. As an example, here you can see example of a simple stateless EJB. This is under EJB version 3.0. In this code, main points to note about on this code use standard import statement to import metadata annotations you use in the bin file. Annotations that apply only to EJB 3.0 are in Java x.EJB package. Annotation that can be used by other platform Enterprise Edition Java EE version 5 components are in more generic packages such as Java Interceptor or Java annotations. The service bin file is a plain Java file that implement Java service, implement the service business interface. It is not required to implement any EJB specific interface. This means that the bin file does not need to implement the lifecycle methods such as EJB create and EJB passivate that were required in the 2.x programming model. The class level at stateless metadata annotation specifies that the EJB is of type stateless session. The class level at transaction attribute never annotation specified that the EJB never runs inside of a transaction. The class level annotation exclude default interceptors. Annotation is specified that the default interceptors, if any, are defined in the jar.xml deployment descriptor file, should never be invoked for any method invocation of this particular EJB. Here you can see example of simple stateful EJB as an example 2. This is in the version EJB version 3.0. Here use standard imports statement to import the metadata annotations you use in the bean file. Annotations that apply to EJB 3.0 are in the JavaX EJB package. Annotation that can be used by other Java platform, Enterprise Edition, Java EE version 5 components are in the more generic packages such as JavaX Interceptor or JavaX Annotation. The account bean file is a plain Java file that implements the account business interface. It is not required to implement any EJB specific interface. This means that the bean file does not need to implement the lifecycle methods such as EJB Create and EJB Passivate that were required in the 2.x programming model. The class level at stateful metadata annotation is specified that the EJB is of type stateful session. The class level at transaction attribute never annotation is specified that EJB never runs inside of a transaction. The class level at remote annotation is specified the name of the remote interface of the EJB. In this case, it is the same as the business interface account. The class level at interceptors example dot audit interceptor dot class annotation is specified the interceptor class that is associated with the bean file. This class typically includes the business method interceptor method as well as lifecycle callback interceptor methods. The field level at EJB annotation specified the annotated variable service is injected with the dependent service bean stateful session bean context. The data type of injected field service is the business interface of service of the service bean. EJB. The following code in the say hello from account bean method shows how to invoke the say hello from service bean method of the dependent service bean. Service.sayHello from service bean. The method level at exclude class interceptors annotation is specified that the at round invoke method specified in the associated interceptor class audit interceptor should not be invoked for the say hello say hello from account bean method. The method level At predestroy annotation is specified that the EJB container should invoke the predestroy method before the container destroyed an instance of the account bean. This shows how you can specify interceptor methods for both business methods and lifecycle callbacks in the bean file itself, in adding to using an associated interceptor class. As an example 3, we can consider this. Implement the entity bean class. Here in this we can see the code segment here. Here in the full code, target methods for the method that are declared in the home interface, which include the EJB create and EJB post create methods with parameters matching the associated create method defined in the home interface, and finder methods other than EJB find by primary key and EJB find all that are defined in the home interface, and the container generates EJB find by primary key and EJB find all methods implementation, although you must still provide an empty method for each of these. Any home interface business method which are prepended with EJB home and in the bean implementation, for example calc salary method, it is implemented in the EJB home calc salary method. The business logic methods that are declared in the component interfaces, the methods that are inherited from javax.ejb.entitybean interface. So this is a segment of the class here. As an example 4, we can consider message driven bean class. For the code for the simple message bean class illustrate that the requirements of message driven bean class. It must be annotated with message driven annotation if it does not use a deployment descriptor. Class must be defined as public. The class cannot be defined as abstract or final. It must contain a public constructor with no argument. It must not define finalize methods. It is recommended but not required that a message driven bean class implement the message listener interface for the message type it supports. A bean that supports the JMS API implements javax.jms.message-listener interface. Unlike session beans and entities, message-driven beans do not have the remote interface or local interfaces that define client access. Client components do not locate message-driven beans and invoke methods on them. Although message-driven beans do not have business methods, they may contain helper methods that are invoked internally by onMessage method. For the Glassfish server, the @message driven beans at message-driven annotation typically contains a mapped name element that specified the JNDI name of the destination from which the bean will be consumed messages. For complex message-driven beans, there can also be an activation config element name containing activation config property annotation used by the bean. A message-driven bean can also inject a message-driven context resource. Commonly, you use this resource to call the set rollback only method to handle exception for the bean that uses container managed transactions. As an example 5, we can consider this. To create an EJB, you must perform these steps. Step 1, create a remote interface for the bean. The remote interface declares the methods that a client can invoke. It must extend javax.egb.egb object. Step 2, create a home interface for the bean. The home interface must extend javax.egb.egb home. In addition, it defines the create method for your bean. Implement the bean. This includes following: the implementation for the methods declared in your remote interface, the methods defined in either javax.egb.sessionbean or javax.egb.entitybean interfaces. For the differences between these type of beans, then the EJB create method with parameters matching those of the create method defined of the home interface. Step 4, create the bean deployment descriptor. The deployment descriptor specified properties for the bean. Step 5, create an EJB-jar file containing the bean, the remote home interfaces, and the deployment descriptor. The EJB-jar file must define all beans within your application. So this is under Oracle 9.9. As an example 6, we can consider EJB application configuration. This is done under jboss.xml file in jboss application server. In the EJB application, you need to modify jboss.xml descriptor file for each stateful session bean and add the clustered tag. In the bean configuration, only the clustered tag is mandatory to indicate that the bean works in a cluster. The cluster config element is optional and its default attribute values are indicated in the sample configuration here. The session state manager GNDI name tag is used to give the JNDI name of the HA session state service to be used by this bean. The description of the remaining tags is identical to one for stateless session bin. Actions on the clustered stateful session bin's home interface are by default load balanced. Round robin anymore and will stay sticky to the first node in the list. As an error example, we can consider EJB 5069 error message. The bean's home or local home does not define a no-arg create method. Solution: check the home or local home interface for the appropriate create method signature. Running the verifier will help identify the error as well. This is occurred in application server Sun Java Communications Application Server 1.0. Now we are focusing on database files. The physical files where our information resided on disk. Oracle has several types for data files, each for different purpose. Database data files, control files, online redo logs, parameter files, other database related files. Here you can see EJB architecture. Enterprise Java beans, EJB technology define a model for the development and deployment of reusable Java server components called EJB components. EJB component is a non-visual server component with methods that typically provide business logic in the distributed application. Remote client called EJB Client can invoke these methods, which typically result the updating of the database. Since ES server uses COBA IIOP protocols, EJB components running on a SS server can be called by any other type of ES server client or component, even COBA client using ORB from the other vendors that are compatible with COBA 2.3. Here you can see application server. The application server contains EJB container and can contain other features such as web application container to host web components such as Java server pages and Java servlets. ES server is an application server. You can see EJB container. The EJB container runs EJB components and provide required services such as enforcing application security constraints, managing transactions that involve multiple components and databases, and providing naming service that maps components and the resources to the logical names. The container provides the infrastructure required to run distributed components, allowing client and component developers to focus on programming business logic. And not system level code. EJB client. An EJB client usually provides the user interface logic on the client machine. The EJB client makes calls to remote EJB components on a server and needs to know how to find the EJB server and how to interact with EJB components. EJB components and web components can act as an EJB client by calling methods in another EJB component. Session beans and entity beans. EJB components can be of two types. Most applications include session beans to be invoked directly by clients. Session beans provide the interface between base clients and the server-side implementation of the application. Entity beans provide an abstraction of an object that is stored in a database. Entity beans are not typically invoked directly by base clients. All types of EJBs are implemented by a Java class that contains implementations of remote interface methods. And additional methods for cycle management. And client interfaces client interfaces an EJB client does not communicate directly with EJB component. The container provides proxy objects that implement the component home and remote interfaces. The component's remote interface defines the business methods that can be called by the client. The client calls the home interface methods to create and destroy the component's logical name to the proxy objects that implement the home and remote interfaces. The proxies contain generated code required to invoke component over the network. Beginning in EJB version 2.0, EJB and web components running in the same server can execute EJB components using the component local interface. Using the local interface can improve performance. If an EJB component is not meant to be invoked directly by client application, you can include local interfaces for the component. Here you can see a web client is connected to JSP and servlet. JSP and servlets are inside web application container. Web application container and EJB container inside application server. JSP is connected to local home interface and local interface. Servlet is connected to local home interface and local interface. EJB client is connected to home interface and remote interface. Session bean and entity bean are inside EJB container. Session bean is connected to local home interface and local interface. Local home interface and local interface is inside entity bean, and entity bean is connected to database. Here you can see a database storage structure. This diagram shows the logical, physical, and recovery related structures of the database and relationships between them. Dotted horizontal lines divide the image into three sections. Top section shows logical structure, middle section shows physical structure, and the bottom section shows recovery related structures in the flash recovery area. In the logical the logical structures are all table spaces. Each table space point to a data file or temp file, which are physical structures. Other physical structures include control files, a server parameter file, and a password file. Here you can see the physical structures include the control file, server parameter file, and password file, and temp file, and data files. Flash recovery area contains following structures: backup of the server parameter file and control file stored in an archival format called a backup set. Another backup set containing a backup of the data files, other online redo files, redo log files, and archived redo files, which are copies of redo log files after they are filled. They are filled. Oracle Database Express Edition, Oracle Database XE, is composed of following storage structures: logical structure, such as table spaces, are created and recognized by the database only and are not known to the operating system. Physical structures are those that can be seen and operated on the from the operating system, such as physical files that store data on disk. Recovery related structures such as redo logs, and database backups are used to recover the database after an operating system failure, Oracle instance failure, or media disk failure. Recovery related structures are stored in automatically managed disk storage area called flash recovery area. Oracle Database XE completely automates the management of its logical and physical structures and flash recovery area storage. You use Oracle Database XE graphical user interface to monitor these structures, mostly to understand how much storage your application have used so far, how much free storage remains, and whether more space is needed for backups. Um, so here you can see logical structures, physical structures, and flash recovery area. In system table space, syst or AUX table space, undo table space, users table space, and temp table spaces space are in logical structure here. Control file, server parameter file, data file, data files, temp file, and password files are in physical structures. So system table space, systox table space, undo table space, and users table spaces space are connected to data files. Temp table space is connected to temp file. Here you can see backup set, control file, and password parameter file, and backup set data files. Online redo logs and archive redo logs are in data flash recovery area. Control file and server parameter files are connected to backup set. Data files are connected to backup set with data files, and online redo logs are connected to archive redo logs here. As an example, you can see this one-to-one relationship example. In example here, we configure EJB dash jar.xml file. The environment is Oracle application server log. Oracle application server. The employee example define one-to-one unidirectional relationship in which each employee has only one address. This relationship is unidirectional because you can retrieve the address from employee, but you cannot retrieve the employee from the address. Thus, the employee object has a relationship to its address object. The EJB-jar.xml file has defined the following. Configure each entity element within enterprise-beans section for each of the entity beans involved in a relationship. For example, this includes entity element of employee with EJB name of EMP bean, and entity element for the address with the EJB name address bean. Configure the EJB relationship element within relationships section for the one-to-one relationship. For example, it define following. An EJB relationship's role element for the employee being that define the cardinality of as 1 as it's at in its multiplicity element. The relationship role source element define the EJB name as EMP bean, which is the same name in the entity. And EJB relationship role element for the address bean that's define its cardinality as 1 in its multiplicity element. The relationship role source element define EJB name as address bean, which is the same name in the entity. Element. Configure a CMR field element in the EMP bean a relationship that points to the address bean. The CMR field element define address as the address bean reference. This element name matches the get and set method names, which are named get address and set address. These methods identify the local interface of the address entity bean as the data type that is returned from the get method and passed on to the method. As an example 2, we can consider QA, PM, WA is EJB data. This data includes information about applications with enterprise Java beans EJB running on WebSphere application server. Each record represents one type of enterprise beans per application module per interval. If there is no bean activity for a particular EJB type, then no record is written. As an error example, we can consider exit status 1. Error in executing the subcommand start database. The start database subcommand start the Java DB server that is available for use with Glassfish server. Java DB is based upon Apache Derby. Use this subcommand only for working with application deployed to the server. This is in the environment Oracle Glassfish server 3.1.2 and 3.1.2.2. So this is the end of my presentation. Thank you very much for watching it.